Hey students, on this clip we're going to be going over two examples on how to solve quadratic equations by using the completing the square algorithm, okay? So let's write down the title of the notes and then go ahead and try the two examples. So we are expected to solve, instructions are as follows, write this down, solve the given quadratic equations by completing the square. By completing the square, and then prove that your answers, your results is correct. Okay, so you're going to find the solution by using completing the square method, and then you're going to prove that your answer is correct. All right. So for number one, we have the quadratic equation x squared plus 2x plus minus 15 equals 0. Okay. So is this a perfect square trinomial? I don't know yet. So we know that 15 is not a perfect square because it doesn't have a square root. So what I'm going to do is I'm going to create a perfect square trinomial, all right, on the left side. Since 15 doesn't qualify, it's not a perfect square, I don't need to do a check. I simply move 15 over to the other side, and then we're going to go ahead and create a perfect square trinomial. So I'll add 15 to both sides. And then I'll have x squared plus 2x equals 15. Now to complete the square, all we just have to do is we need to add b over 2 squared to both sides, okay? If I add b over 2 squared to both sides, the 15 cancels out, then it was a perfect square trinomial, but it's not going to cancel out, okay? So let's do this. So b is, this is a, and this is b. B is 2, so what do I do with 2? I divide it by 2, which is 1, b over 2, and then we're going to square it, which is 1. Okay? So we'll add 1 to both sides to create a perfect square trinomial on the left side. So we're going to have x squared plus 2x plus 1, this one that we generated here, that equals 15. Since I added 1 to the left side of the equation, to preserve equality, I have to add 1 to the right side. All right? So now that we have a perfect square trinomial on the left side, I'm going to use a factoring trick for perfect square trinomials. To factor this, I'll simply read the first term and the last term, and then bring down the first sign. Okay? So that's the factored form of this trinomial is going to be x, because the root of x squared is x, plus 1 quantity squared, equals 15 plus 1 is 16. All right? Now what I'm going to do next is I'm going to take the square root of both sides. I'll read the left side, and I'll read the right side. Anytime you take the square root of a square, you end up with the absolute value. The absolute value of quantity x plus 1 equals square root of 16, which is 4. Okay? Our absolute value is the same as plus or minus. So we have plus or minus x plus 1 equals 4. Now I'm going to divide both sides by plus or minus 1 to move the plus or minus to both sides. You can imagine that there's a 1 in front of here. Okay? So to move that plus or minus to the left side, I will divide the left side by plus or minus 1 and divide the right side by plus or minus 1. Okay? So on the left side, this plus or minus is canceled. So I'll have x plus 1 equals plus or minus 4 divided by 1 is just 4. All right. So at this point in time, we can split our equations into two, the plus side and the negative. So for the negative, we'll have x plus 1 equals negative 4. And then for the positive, we have x plus 1 equals positive 4. All right, so to finish this off, on the left side, I'll subtract 1 from both sides. And then we have x equals, this one's cancel, add up to 0, equals negative 5. On the right side, same procedure, we'll subtract 1 from both sides. and then we'll have x equals 3. Okay, so our solution set is -5 and 3. All right. Now we're also asked to prove that our answer is correct, so we're going to go ahead and do a short proof to show that this answer is actually the solutions to this original quadratic equation that we had up here. All right. So let's write down the title. We're going to write proof that um, -5, comma, and 3. Let's write -5 and 3 are solutions to the original problem x squared plus 2x minus 15. Okay, so this is what we're going to do. All right, so what we're going to do is to make this proof, all we have to do is we're going to substitute these two values into the original equation, equals 0. Sorry about that. And then if we get a true statement, then we can conclude that our answers are accurate. All right, so first test is x equals -5. All right, so we're going to test that first. We're going to test x equals -5. So we're going to plug it into this original equation. So we're going to have -5 quantity squared by substituting -5 for x plus 2 times -5 minus 15 equals 0. All right, so we're plugging in -5 for x in this equation, we end up with this equation right here. Okay, so this is a true statement or false statement. We'll just simplify using order of operations. Please excuse my D and tally and see what happens. All right, so -5 squared is 25. 2 times 5 is -10 minus 15. Is this equal 0? Is it? Well, let's see. If I simplify further, I have 25 minus 25. Is 25 minus 25 equal 0? 25 minus 25 is 0. Is 0 equal 0? Absolutely. So the first answer checks. So we're feeling confident now, but we also have to test the second result, x equals 3, to see if, to make sure that our two answers are accurate. Okay, it doesn't suffice to show that only one is accurate. So I'm going to plug in 3 into my x's here and then execute the check. Okay, so we have 3 squared plus 2 times 3 minus 15. Question, if I simplify this left side, is it going to be equal to 0? Well, let's see. 3 squared is 9. 9 plus 2 times 3 is 6 minus 15. Is that equal to 0? 9 plus 6 is 15. Is 15 minus 15 equal to 0? 15 minus 15 is 0, right? Is 0 equal to 0? Absolutely. Okay. So what is our concluding remark going to be since it was checked out? So we just write a concluding remark since -5 and 3, well, since, sorry, let's say since substituting, let's change that. Sorry about that. Since substituting -5 and 3 into the original equation yields a true statement, then they are solutions. They are solutions to the equation. Okay, they are solutions to the equation. All right. So anytime you plug in a result into an equation and get a true statement, that result is a solution to the equation. Okay. All right. So there you have it for question number 1. All right. Now let's move on to the next problem, number 2. All right. So for 2, we have let's change this. So for 2, we have the equation x squared plus 12 equals 4x. Okay. All right, so let's take a look at this equation. First of all, we need to put this in standard in standard form, setting it equal to 0. So to accomplish that, we'll just move the 4x to the left side. So subtract 4x from both sides. So we have the quadratic in standard form, right? So we have x squared minus 4x plus 12 equals 0. Remember, the standard form for quadratic equations is ax squared plus bx plus c equals 0. Okay, you just have 0 the left side on the right side and everything else on the right side. So that's what I'm attempting to do here. So take a look at this equation. It's now in standard form. Now, to solve this, using completing the square, it's obvious this is not a perfect square because this last term here is not a perfect square. That's just one easy way to tell that this is not a perfect square. So to create a perfect square trinomial on the left side, I need to move this number out and find a number that makes this a perfect square trinomial. All right. So to accomplish that, what I'll do first is move the 12 over, so subtract 12 from both sides, and then we'll have x squared minus 4x equals negative 12. You also have to make sure that you don't have any coefficient for x squared, and that's the case here. We don't have any coefficient here, so that's perfect. So to find the term that makes this a perfect square trinomial, I have to add b over 2 squared to both sides. So this is a, the coefficient of a is 1, which is perfect, and b is negative 4. Okay, so since b is negative 4, I'm going to divide it by 2, which is negative 2, and I'm going to square it, which gives me 4. Okay, so b over 2 squared is 4. So this 4 completes the square on the left side and on the right side. So I'm going to write x squared minus 4x, and then I'll insert that 4 that makes the left side a perfect square trinomial. So in order to preserve equality, whatever I add to the left side, I have to add to the right side plus 4. So we're going to have a perfect square trinomial on the left side. All right, so let's apply the factoring trick to factor perfect square trinomials. You just read the first term and the last term, and then bring down the middle sign. So the factored form of this trinomial is going to be x minus 2 quantity squared, and that equals minus 12 plus 4 is negative 8. Okay. Now to get rid of the square, we use its opposite, which is square root. So we root both sides. So we're going to have on the left side, since the square root of a square cancels out, we're going to have the absolute value of x minus 2 equals, now if you take the square root of minus, it becomes I. And what do we get when we simplify root 8? Let's work that out on the left over here. So the square root of 8, we can break 8 down. We have 2 times 4. Break it further, 2 times 2. These two 2's repeat, so they can come out as 1, right? They break out as 1 because the square root of 2 or 4 is 2, and this one stays behind because it doesn't have any partner to break out of the square root with. So root 8 is simply 2. These two 2's that break out as 2. Root this 2 that's left there, 2. Okay? So the square root of negative 8 is going to be 2. Put the 2 in front of the I. 2i. For this 2 right here, root 2. Okay? All right. Now, if we break down the absolute value symbol, it's going to become plus or minus. So we have plus or minus x minus 2 equals 2i root 2. To get rid of this plus or minus, we can imagine there's a 1 right here. So we'll basically divide both sides by plus or minus 1 to move the plus or minus to the right side of the equation. All right, so on the left side, the plus or minuses cancel out. Plus or minus, it cancels out. So we have x minus 2. X minus 2 equals plus or minus 2i root 2. Okay, so this is where we're going to proceed to split the equation into 2 parts so we can solve them independently. The left side will take the negative. X minus 2 equals negative 2i root 2. And then on the right side, let's do the positive 1, so x minus 2 equals 2i root 2. Okay, now let's finish this off. On the left side, we're going to add 2 to both sides. Add 2, add 2. So we're going to have x equals 2 minus 2i root 2. So that's the first root. And then on the right side, we'll add 2 to both sides. Add 2. And then we're going to have x equals 2 plus 2I root 2. Okay? So for this problem, our solution set is given by x equals, squiggly bracket, 2 minus 2I root 2, and 2 plus 2I root 2. Okay? So there you go. So now we have to prove that our answer is correct. So proof that 2, we can jumble them together, plus or minus 2I root 2 are solutions to the original problem, which is x squared plus 12 equals 4x. Okay, so we're going to test them one by one, and hopefully we get a true statement with each substitution. Okay, so first one, we're going to test x equals 2 minus 2I root 2. All right, so I'm going to plug it into this equation, see if we end up with a true statement. Okay, so we're going to have 2 minus 2I root 2, quantity squared, plus 12 equals 4 times 2 minus 2I root 2. Actually, we don't know if it's equal yet. Is it equal? So I'm going to work this out and see if we end up with a true statement. Okay? So this one, we're going to just follow it out. So we have 2 minus 2I root 2 times 2 minus 2I root 2 plus 12. And this side is easy. We just simply distribute, right? So we have 8 minus 8I root 2. Okay? On the left side here, we're going to distribute 2 times 2 is 4 first, and then we'll do outer. 2 times 2I root 2 is going to be 4I root 2. You simply multiply the 2 and the number on the outside. Negative 2I root 2 times 2 is also going to yield negative 4I root 2. And then minus times the minus for the last one is plus. 2 times 2 is 4I squared. And then root 2 times root 2 is 2 times 2, because the square roots cancel out. All right, or you can think of it as root 4, which is just 2. Okay, so root 2 times root 2 is root 4, which is 2. Okay, all right, let's simplify it a little bit further. Oh, wait, plus 12. Let's not forget this plus 12 down here. Question is it equal to 8 minus 8I root 2? Is it? All right, let's move on. So we'll combine. On the left side, we're going to have 4 minus 8I root 2. You simply add the coefficients on the outside, don't add anything else. And then this I squared makes this a negative, so we have minus 8 plus 12. Is it equal to 8 minus 8I root 2? Is it? Simplify further. 4 minus 8 is negative 4 plus 12 is 8. So we combine this, and this. We'll have 8 minus 8I root 2. Is that equal to 8 minus 8I root 2? Absolutely. So our first check works out nicely. Okay. All right. Now let's try the second one. Let's test the second one again. See if we already got a true statement. If we do, then we'll celebrate because our answer is correct. All right. The next thing we're going to do is we're going to test. We're going to go ahead and test the other solution. X equals 2 plus 2I root 2. If you notice, this is a conjugate of this, all right? So we're going to plug it into the original problem that we have up here, our test. So the question is 2 plus 2I root 2 squared plus 12, is it equal to 4 times 2 plus 2I root 2? Is it? Let's solve this out. On the left side, we're going to have the answer to the question is 2 plus 2I root 2 times 2 plus 2I root 2 plus 12. What's that? Is it equal to? So when you have a square, you just write it twice, plus the 12. Distribute the 4 to both of these, and then is it equal to 8 plus I root 2. It's real similar to this. The only difference is we have a minus here. That's a plus. You have two minuses here. You have pluses here. Okay? So let's pull this out. First, outer, inner, last. First is 2 times 2, which is 4. Outer is 2 times 2I root 2, which is plus 4I root 2. Remember, you just multiply this 2 and this 2 right here. Positive 2I root 2 times 2 is going to be plus 4I root 2. Last but not the least is 2I root 2 times 2I root 2 is positive. 2 times 2 is 4. I times I is I squared. Root 2 times root 2 is root 4, which is just 2. Okay? Or root 2 squared and the squared and the squared cancel out, so you have 2. Let's not forget the plus 12. Question is it equal to 8 plus 8I root 2? Is it? All right, so let's simplify further. We just bring down the 4. And then when we add this 2, we have plus 8I root 2. Now, I squared is negative 1, so it changes this to a minus. 4 times 2 is 8 plus 12. Question is it equal to 8 plus 8I root 2? Is it? So you combine 4 minus 8 plus 12. We have 4 minus 8 is negative 4 plus 12 is just simply 8. 8 plus 8I root 2. Is it equal to 8 plus 8I root 2 on the right side? Absolutely. So it checks out nicely. Okay. So let's write a concluding remark for the proof that we just did. So since substituting 2 minus 2I root 2 and 2 plus 2I root, oh, what did I just do? 2 plus 2I root 2 into the original equation yields a true statement. If it yields a true statement, our results, namely 2 plus 2I root 2 and 2 minus 2I root 2, our results are correct. Okay? So there you have it. So thanks so much for paying attention to this presentation. You can feel free to subscribe to my videos here so you can get updates to other cool videos such as these, and also subscribe for updates. More please can be found on myteststuff.com. Thanks again and have a wonderful day.